Well, good morning, guys. I did a WebEx this morning. Put my head in there. You don't need to see my pretty face. Did a WebEx this morning on RT39 that brought in a couple new things of the total rise and as well the area of the roof. So we're going to go into this. I will go through the entire worksheet here, but that is the only things that are new. So if you choose, you may skip right to the end to look at questions. What do we have? Number 12 through 15. But I will go through it step by step here again. I've written it all on the board here. I have a building that is 27 foot 0.5 in width by 39 foot 0.25 inch in length. Pitch 724. Got a couple different color markers here that I'll skip through. If my pitch is 724, as carpenters, one of the first things we want to do is change out the slope. To change that by slope to slope, we multiply it by 24, gives us a 7-inch rise. So let's fill in our unit triangle over here. We know if we have a 7-inch rise per unit of run, we can look on Stanley square or on a rafter square, and it will give us 13.89. Because it's a 1-to-1-to-1 ratio, that is inches as well. Every time we go over 1 foot of run, we will go up 13.89 inches up the slope of the roof, or the line length per foot of the common rafter. Projection 15 1/8 inches. So around this building, we will have a projection of 15 1/8 inches. And that'll continue all the way around the entire building. So number one, we figured it out right off the bat. Unit rise, 7 inches. Number two, ask us for the length per foot of the common rafter. So our line length per foot of common rafter, line length per foot or common rafter is equal to 13.89 inches. Half the span as a decimal. Well, our span is 27 foot 0.5 inch. If we take that and convert that to decimal feet, we end up with 27. Then we take half of an inch divided by 12 inches to give us 0.042 units. So for number three, we're going to take our span and we're going to divide it by 2. 27.042 units. Divide that by 2 will give us our run of 13.521 units. We now know that this 13.521 units of run is right here. That is half of our building. So halfway across, 13.521 units of run for this common rafter. Number 4 asks us for the decimal length of the common rafter. Well, our rafter going up this slope of 7 in 12 runs 13.521 units. Each unit will go up the slope in line length of 13.89 inches. So we then take our run times our unit line length, or 13.521 units times 13.89 inches to give us 187.807 inches. Remember, we're taking our units times inches. We will end up with inches. I'm going to change that over to feet and decimal feet. By dividing by 12, I get 15.651 feet. Number 5 asks me for the line length. Well, I'm just going to convert that over to feet, inches, and fractions of an inch. I'm going to take that and change it to 15 foot. Take my decimal 651, multiply that by 12 to give me inches. Will give me 7. And the remainder, timesing it by 16 to give me 16ths of an inch. 13/16. Number 6, our projection here as a decimal. So how many units of run do we have in our projection? Well, we have 15 1/8 inches. 15 1/8 inches. Divide that by 12 to give me 1.260 units. So my projection runs 1.260 units. So my overhang now. What is the length of my overhang? Number 7. Pardon me, what have I got? 1, 2, 3, 4, 5. 6 is the projection as a decimal. 7, decimal length of the overhang. I have 1.260 units. Again, I'm using the same triangle. I'm going up 13.89 per unit inches in length to give me 17.50 inches. Change that over to feet. I get 1.458. feet. So that is the line length of my overhang. This one here is the line length of my common rafter. When I change that to feet, inches, and fractions of an inch, I'll take that and it will convert over to 1 foot 5.5 inches. 17.5, 1 foot 5.5 inches. So number 9. Nominal length of my common rafter. I know that up here the line length of my common rafter was 15 foot 7 and 13/16. I know that the line length of my overhang is an additional 1 foot 5.5. If I add those two together, and then I have to order a nominal length. So if I'm ordering a 12, 14, 16 nominal lengths of lumber, starting at 8 foot, come in increments of 2 feet. So here we have 15 foot 8 plus 1 foot 5, 15, 16 foot, that's over a foot, 17 plus, so it's going to be an 18 footer. We can confirm that by adding these two decimal feet together. Got 15.651 feet plus 1.458 feet to give me a total of 17.109 feet. So I know that I have to order an 18 foot. You want to see that? Number 10 goes into the number of common rafters. Number of common rafters. I know that the length of my building is 39 foot 0 1/4 inches. I know that my rafters are 2x4s, 16 inch on center, starting at one end. 39 foot 0 1/4 inches. If we convert that over, let me punch that into my calculator. I don't have that number written down. I have 1/4 of an inch, 0.25 plus, pardon me, divide that by 12 to change it into feet. Gives me 0.0208 plus my 39 feet. Gives me 39.021 feet. 39 16.021 feet. I can change it over to inches and then divide by 16" on center, or I can just times that by 0.75, which is the equivalent of doing the previous, to give me 29.265 spaces. So I'll just break down here. 39.021 feet times 0.75 equals 29.265, and that is spaces, because what I did here is took my feet times by 12 divided by 16" spaces, gave me 29.265 spaces. Now this here is spaces. I need one to start and one to end. So 29.265 spaces means that one space, one rafter, two space, two rafters, three space, three rafters, all the way up to here to 29 spaces, 29 rafters. Well, to get one on the end, I have to round this up to 30 spaces. It truly is 30 spaces. Just the last space is only 0.265 of a space. So my last one here, 30 spaces, 30 rafters. I don't have one here to start because I did one space for my first rafter. So I then have +1 to start. That is just one side of the roof. So that's 31 rafters on this side. Remember, I got a ridge down the center, so I have 31 rafters on this side as well. 62 common rafters. Number 10B, verge rafters. Well, again, we have a projection all the way around. So out here, to carry our sheathing all the way across, we need to end with a rafter there. This is our verge rafter out on the end. It's the same as a common rafter, other than we do not cut the bird's mouth in it. So we have 4 verge rafters, plus 4 verge rafters. That is 10B. This is I'm just going to grab a rag here. So nothing new there from anything that we've done. I'm going to erase this and continue on. So there's 1 to 10 done step by step for you. I'm going to erase this. That red marker doesn't like to come off. A little bit messy up there. All right. Number 11. Number 11 is asking us for the board footage. We know that we have 2x4 rafters. We know that we had, oh, I went and erased it. We had 62 common rafters plus 4 verge rafters. We have 66 rafters. Each of them is 18 feet long. 18.0 feet if you wish. And we're going to divide that by 12 to give us our board footage. This will give us an answer of, because I conveniently punched this in, 792 board feet. Next question we have, total rise. Hey, this is a newer one. Here's our section of our building. Here's our theoreticals. We're asked for the total rise. Going back to our unit triangle, every time we go 1 unit in this direction, we would go 1 unit up. So every time I go 1 foot over, I will rise 7 inches. I could take that unit triangle that I've erased a little bit here. Let me just fill those numbers back in. 8, 9, and 7 inches. Every time I go 1 foot in this direction, I will rise 7 inches. So 1 foot over, 7 inches up. Another foot over, 7 inches up. Another unit of run over, 1 unit of rise. I know that the run of my building, we figured out earlier, was half of my span, 13.521 units. My rafter runs 13.521 units. So I know that it is going to go up 13.521 units of rise, which is the equivalent of 7 inches. This is a 7 in 12 roof. So I'm going to take 13.521 units times my unit rise of 7 inches. 13.521 times 7 gives me 94.647 inches. If I divide that by 12, it gives me 7.887 feet. 7.887 feet. So that's how much it is for my total rise. That's my theoretical rise. There's still some height in the remainder of the height above plate of my rafter. Next question we have is the length of the ridge board. Oh, let's change this over. 7.887 is equal to what? 7 foot, 0.887 times 12, 10. Take our remainder times by 16, 5/8 of an inch. Comes up to 10/16, we know it's 5/8 of an inch. So that there is number 12. Total rise. Number of units of run times the unit rise. 13.521 units of run, 13.521 times 7 inches. Number 13, length of the ridge board. You can see to the bottom here. Length of the ridge board, I have the length of my house, 39 foot 0 1/4 inch, plus 15 1/8 inches of projection here, plus 15 1/8 inches of projection here. So I'm going to take for my ridge, length of building, plus 2 times my projection. If I put this all into feet, 15 1/8 of an inch. If I change that over to feet, I get 1.26. Length of the building, 39.021 feet, plus 2 times 1.26. 1 point. Where in the heck is it? Well, let's just do this. 15 1/8 inches. 1 divided by 8 equals 0.125. Plus 15 equals 15.125. Divided by 12 equals 1.260. Just to make sure. 1.260 feet. When I put those all together, I end up with 41.541 feet, which is the equivalent of 41 foot 6.5 inches. So the length of my ridge board is the length of my building plus 2 projections. Our verge rafters will butt into there. If we looked at a side view, this would be our ridge, and here would be our rafter. A verge rafter is identical to a common rafter, except we do not have a bird's mouth because it's not resting on the wall plate. It's hanging out here. Other than that, it's kind of identical. Next question we have, number 14, is the area of the roof. I am going to erase all this. I'm going to draw a big picture of our roof. Here's our roof. That's the outside to outside of walls. We now have projection all the way around this. This is a plan view of what it would look like if we were a bird and we flew over top of here. We have our length of our building. We have the span, or the width of our building. We then have a projection that is hanging over all the way around. If I fill in these numbers from here to here, that's the length of our ridge board. We determined that to be 41.541 feet. The next thing that we need, let me just draw a ridge board down the center here. To determine area, we need length times width. We have to remember that this is a plan view when we're flying over top of this roof. But from the side, this is what our roof actually looks like. If we did a section view, you can see the slope here. So we need to find out that measure of the line length of our common rafter plus the line length of our overhang, which is the total line length of our common rafter. That will now be this length, which is half of our building. So here we can take the line length of our common rafter plus the line length of our overhang, multiply it by the length of our ridge board. That will give us 1/2 of the roof. We'll have to multiply that by 2 to get the entire roof. So here's it. One way to do it. Area of the roof. This marker sucks. Go back to the black. Area is the length of our building plus the 2 projections times line length of our common rafter plus the line length of our overhang is the total line length of the common rafter. Length of our building plus 2 projections, 41.541 feet, times total line length of our common rafter. We did that on the previous as, where do we have our nominal length? 17.109. 17.109 feet. Take that, put it in my calculator. 41.541 times 17.109 equals 710.725 square feet. That is only 1/2 of the roof. Times 2 sides times 2 equals 1,421.450 square feet. I'm just going to write that number up at the top here because I'm going to show you a second way that we can determine the area of the roof. 1,421.450 square feet. So that's area using the total line length of our common rafter so that we can determine the length of that roof while going up the slope. Going to do something similar but a little bit different. We can do the area of the roof and determine what it is on the flat. So on the flat, we can take the length of our building plus the 2 projections times the width of our building plus the 2 projections. That will give us this entire area. Then we know that our roof is at a slope, so we would basically be figuring out the attic area. Now, how much more is our area going to be, or surface area, if we're on this slope? Well, if we look back at our unit triangle, draw it a bit bigger here. We know that we go up 13.89 inches for every 12 inches. This is our area calculated on the flat. We know that our building is up on a slope, and we know that it goes 13.89 inches. So how much longer, or how much more surface area do we need to go up the slope? Think of it this way. What if I put a hinge right here, and I folded this down and follow this arc? It would thus be this much longer. How much is that? Well, I can take my unit line length and I can divide it by my unit run, and it will give me the difference there. So here I have 13.89 divided by 12. 13.89 divided by 12 gives me 1.158. This is what's known as my roofing factor. That is how much longer 13.89 is in relationship to 12. It is about 16% longer. Waste factor, how much bigger? If I added 15.8% waste to 12 inches, I would end up with 13.89. So I can figure out on the flat and then add that much to it, or multiply it by my roofing factor. So here I have the length of my building. So here's area number 2, or area way number 2, using roofing factor. Length of my building plus 2 projections, same as we did the first time. Times the width of my building plus 2 projections times my roofing factor. Here I already have length of my building plus 2 projections, which is the length of my ridge, 41.541 feet. Width of my building, it's going to go back to my worksheet. Width of my building was 27 foot 0.5 plus 2 projections of 1.26. I don't have this written down. Let's punch it in. 27 foot 0.5 inches. Half an inch. Divided by 12. Plus my 27. How long is my building? 27. How wide, pardon me? 27.042 plus 1.26 feet times 2, 2.52 feet. $27.042 gives me 29.562. Bring down my roofing factor. I'm going to multiply this by 41.541. 41.541 times 29.562 gives me 1,228.035 square feet times roofing factor. This here on flat, if we flew over as a bird and we looked down at it, the span of our building plus 2 projections and the length of our ridge board, that's how many square feet it is if we're on the flat. Now if I grab that and pull it up, I grab it from here, pull it up, that's where my roofing factor, this is 1.158 larger than this. So I will take 1228.035 and I'll multiply it by 1.158. $1228.035 times 1.158 of my roofing factor gives me 1,422.069 square feet. It's a little bit different than what we had at the top. It's how much? Half a foot? It's about a half a foot, half a square foot, not very much. The reason it's a little bit different is the rounding that happened right here. If I truly wouldn't have used roofing factor and I would have put these two numbers in, 13.89 and 12, it would have changed a little bit. Just see here, 1228.035 times 13.89 divided by 12. So this is how I determined my roofing factor, and I rounded it to 158. If I go 1228.035 times 13.89 equals, divided by 12 equals, this gives me 1,421.450. Look at that. Identical. It's up to you guys which way you would like to do this. This way, the first way that I showed you, using the line length of the common rafter plus the line length of the overhang, on these worksheets you've already determined that. You've already determined the length of the ridge board, which is the length of our building plus 2 projections. So it's fairly simple to just steal those numbers from the previous questions and plug them in to the length and width. But if you were to walk up to somebody's house and they said to you, hey, can you determine how many shingles I need or how much it would cost to shingle my roof? We could stretch a tape measure out, find the length of the building, find the width of the building. We can determine what the slope is of that house. We know we can measure the projection of the house. So now if we had a house, we measure it out and it's 30 by 40. So let's say we had 40 feet here, we had 30 feet here. We know that we've got a 2-foot projection all the way around. So we know that this house now is 40 plus 2 plus 2, 44 feet. We know that it's 30 plus 2 plus 2 times 34 feet. we determined that the house, we do run a level across. So we can run a 4-foot level, take the rise of what we have, divide that by 4. That will give us our slope of our roof. If we determine it to be a 7 in 12, well, we then just times this by roofing factor, and bam, we have the area of that roof. We now can determine how much ice and water shield do we need, how much synthetic underlay do we need, how many bundles of shingles do we need. We can determine, oh, we might have to re-sheathe this entire roof, so how many sheets of plywood do we need? That's the last question on here, is how many sheets of plywood do we need on this worksheet? So roofing factor can be really beneficial. It can be quick to do estimating as opposed to taking the line length of the common rafter plus the line length of the overhang, then taking the length of the ridge board and working it out that way. Your choice of which way you'd like to do it. There's 2 ways. When you get into level 3, roofing factor, you're going to be using this roofing factor all the time. The last question is, how many sheets of plywood do we need to cover this roof? Well, we have 1,421.450 square feet. We all know that a sheet of plywood is 4 feet by 8 feet for a total of 32 square feet. So take this number, our total area, and divide it by 32. You tell me the answer.